My name is Adam DeHaven. I'm a staff software engineer at Kong, and I'm going to talk to you a little bit about scalable architectures with Vue micro frontends. So this is going to be a little bit different, right? So everybody knows what micro frontends are. We heard from Evan earlier that there's not really first-class support for module federation with Vite. So I'm going to kind of show you a different way to do it, the way we do it at Kong. But again, it's more for the developer experience, right? So we'll get into it a little bit more. All right, so before you dive in, let me give you a little bit of background on Kong's UI ecosystem and our engineering teams. So our primary application is SaaS. It's called Connect. Kong Connect's a unified cloud-native API management platform to optimize the environment. It reduces operational complexity, promotes federated governance, et cetera. So Kong is structured as a single Vue SPA spanning 10 product areas. We have about 10 product and engineering teams that collaborate to enhance functionality over time. So again, we're still like in the, I guess, really large startup phase, but we're building and enhancing features more and more as we go. It's not going. Okay, cool. So let's talk about a little bit our UI engineering teams. So we have over 30 front-end engineers located around the world, collaborating across 10 different teams. We have our UI platform is comprised of a centralized design system and shared Vue component libraries, all consumed by several different host applications. And Connect was originally structured as a monolith, right? So when Connect was getting started, all the code, the front-end code and the back-end code was all in a single monorepo. It made it easier for the devs at the time we were starting up to understand the code and maintain the code base. But as everybody here has probably run into it over time as the app grew, the number of contributors began to climb as Kong started hiring more rapidly, and the architecture was more and more painful as time went on, which ended up causing a lot of bottlenecks. So let's talk about why the need for change, right? So the tipping point for Kong, why we wanted to get away from this monolithic architecture. So first and foremost, again, the developer experience was just bad. We had a monorepo of packages pulled together via imports and symlinks into an SPA, and the entire app could be impacted by the smallest issue. So you could literally change an input and something in a totally different product area, the test may start failing, just things were very unstable. We had multiple owners with different concerns, right? So different teams maintained each area of the app. So each team would put in their own layout, variations of styles, different project settings, different linting settings, and this kind of caused a little bit of chaos depending on where you were working inside the app. We also had inadequate tooling, right? So the dependency version mismatched across the app. There was a lot of conflicting linting rules. Multiple CI pipelines, various coding standards were spread throughout. Again, test failures, right? So that's going to be something I'll harp on a little bit here. You could change something in your product area, and then just tests across the app may just kind of start failing. In your CI, not related. It was more just boils down to kind of like flaky tests, and again, we'll get into that a little bit more in a minute. And this was a huge one for us, right? So a very long-running feedback loop. So if you chose not to run the test locally before you pushed your code up, so if you pushed up your PR, it would build. And again, some of this is even after implementing Vite, right? And you would deploy preview. It would take up to 45 minutes. So once you're ready to merge to production, cool, let's wait another 45 minutes, right? So super long feedback loop, especially if you thought your changes were minimal and weren't expecting a lot of issues. And so with that feedback loop taking forever, the automation around it can be costly, right? So we use GitHub Actions. The high number of PRs with reruns, that put everybody into a queue because we had a limited resource pool in GitHub Actions. So then every minute of automation would also end up costing the company some time and some cash. And so if we look here at a little bit of the timing and the kind of the cost of that feedback loop, right? So linting, building, running unit and component tests, deploy previews would all take about 45 minutes. Doing the same thing against the production deploy and for the release would take another 45 minutes. Our GitHub Actions monthly minutes was close to 300,000 minutes, and this is on the low side. I could only go back so far for numbers, so it used to be even higher. We were merging about 112 pull requests a week and had about 75 host app monolithic app deployments a week. So 90 minutes from creating a pull request to getting that code into production. And so that's basically forever in terms of deploying your code, right? And that's if the tests don't fail. And so I have some people here that are on my team. So like what does anybody do when our tests fail, right? Well, you rerun them. That's what you do. You rerun them over and over, and then maybe you end up looking into it. But that's kind of what we saw around our developers. Was it was just, hey, a test is failing. I'm not familiar with the code. I don't know. It's in another area. Maybe if I rerun it, I'll cross my fingers, and this thing will get over the finish line. So real quick, I'm going to go on a tangent and talk about these test failures, right? So how do test failures impact developer experience? So first off, seemingly unrelated failures. Sorry. There we go. They cause frustration and fatigue among different engineering groups, right? So as more and more teams are working alongside each other, where only some engineers are familiar with certain tests or certain product areas, they just get frustrated, right? Like, I touched this code, why are the tests over here failing? And inevitably this like perception comes in that the tests are just flaky, right? So this leads to quick fixes and hacks, and again, smashing that rerun button in GitHub Actions, which ends up costing the company time and money. And so that being said, we decided to look into some new architectures with Connect, right? Because this monolith was just not working for us. And so let's talk about some of the advantages a micro-frontend architecture provides and how we were able to solve many of our developer experience issues by moving towards this architecture. Okay, so the first thing, we are still in a monorepo, but we kind of looked at it differently and said, how can we do this better, right? So we moved to PMPM instead of Yarn. And so why PMPM, right? So it provides much more performant dependency installation and efficient usage of the node module's disk space. The monorepo that, supports a wide array of packages across multiple engineering teams, and over time, you'll just accumulate more and more and more dependencies. So performance and efficiency when handling those dependencies is critical. So we wanted to also enable autonomous team-based development, right? So each team's app in this new architecture should be able to be developed, tested, and deployed independently and in parallel, right? So teams can release new features. The other teams in the ecosystem don't even have to care what's going on in this other app. Reducing bottlenecks, right? So this was huge for us. We basically created an integrated CLI with TS Node that'll scaffold up a new app. So if you wanted to scaffold up, let's say, a new micro front end for your product area, you literally run a command, you update a Terraform file with in CloudFront, and you're up and running. There's really nothing else to it, right? And so as more and more people are contributing, we wanted to make the context switching cost of moving between apps a lot less, right? So because we're in this monorepo, we can standardize a lot of things as far as the structures, the linting rules, the coding standards, things like that. And we also took a ton of time to write a lot of internal documentation, right? Like, I was talking to the FormKit team that's here. You know, external documentation is great, and that's what gets all the polish. But a lot of times the internal documentation kind of suffers or just doesn't really get the attention it needs. So at Kong, we've tried to start doing a way better job of documenting these things to reduce the bottlenecks for teams so that there's no questions, right? You have everything you need, you just get up and running. And the last thing is that this architecture is scalable, right? So as I mentioned, as our platform grows, all you need to do is spin up a new app, and all of a sudden you have a new product area with your own ecosystem that you can go and develop in. And introducing new apps is pretty trivial. The next thing is a centralized core. So when you have a lot of different micro frontends working in the same environment, there's a lot of this core logic that you need that every app is going to need in order to be in that ecosystem, right? So things like permissions, authentication, session management, things like that. And as well as the UI layout, right? So everything needs a global UI. We need a nav bar, a sidebar, things like that. And so we created this centralized component that basically provides this to all the micro front ends, and then the downstream apps, again, don't really have to care. They just work. And I'll get more into that component here in a minute. So testing is finally easy, right? So at Kong, we use vtest for unit tests and some component tests. And then we use Cypress for all of our end-to-end and also some of our component tests. But in the monorepo, both the testing frameworks have a base configuration, so it's essentially standardized across the repo. And then it allows each app to extend that testing strategy as needed. And so you can share things like shared commands or different stubs or interceptors or whatever you need, and then extend that if your app needs something more specific. We also implemented a lot of shared tooling, right? So things like TypeScript, ESLint, and other configs were put in place to establish that baseline of coding standards that we want across all of our code base. And then that obviously gives us things like type safety and code quality and those sorts of things. And finally, Git hooks, right? So I mentioned earlier how much time we were spending on GitHub Actions. So we actually now have a lot of pre-push hooks then enforce all of these coding standards, right? Because we were seeing a lot of code get pushed up to GitHub Actions that would just immediately fail, right? The initial steps would go on, it would try to do the build, it would try to do the linting, and maybe we're spending 10 minutes of PR on code that we know is gonna fail, right? So we implemented these pre-push hooks to essentially enforce all the ESLint, stylelint, type checking, things like that before the code is pushed. It's a little bit more of a burden on the developer, right? Because if your code isn't up to spec, maybe you can't push it up, or maybe it takes a minute to run this. But in the end, it's worth it and it's better for everyone because we don't tie up our resource pool in GitHub Actions with code that is not even gonna pass like those first initial steps. So let's talk a little bit about how we set up this micro front end. Like how did we split up this monolith, right? So at Kong, our engineering and product teams are generally organized by our top level apps that you see here in the sidebar. And so it was natural for the new architecture to kind of follow that same pattern. So we decided to split the application vertically by product domain, meaning each sidebar item you see here is essentially its own micro front end. And this allows for, again, that anonymous team-based development that we talked about earlier, where each team essentially owns everything within their app. So what does the Monorepo look like, right? So let's walk through this a little bit. So this first folder we have is our apps folder, right? So each app within this top level directory is its own PnPm workspace and is isolated from any other app at the same level, right? So everything is completely independent between all of these apps. There's no code sharing, there's no shared imports. They are all essentially a separate Vue application. Up here at the top, we just have our shared CI/CD workflows. And then these files, we have the shared testing configurations, right? So we have our base level Cypress config, base level vtest that sets everything up just so the apps don't have to care. We have a folder for documentation. Again, we're focusing a lot on those docs. So this contains everything from how to create a new app to how to do different testing methods and things like that that you need access to. Shared configs, right? So the left hook, we use left hook to manage our Git hooks. We have ESLint configs. There's more, obviously, but gives you the good idea, again, of those base level settings. Package JSON, so in the PnPm Monorepo, this really just handles all the shared dev dependencies, right? So if you're using Axios or Vue, you can add that as a dependency here, and then all of your apps in your PnPm workspace can just share and utilize that same dependency version. So if we were to, let's say, bump Vue to 3.5 when it comes out, we can do that on a global scope, and we don't have to wait for each app to upgrade. Now, obviously, if some apps have some breaking changes or things like that that need to be addressed, we will do so. But trying to line up all those dependencies between apps tries to keep everything between all the micro front ends essentially on par. Same thing here for the TS config and the Vite config, right? Just shared base configurations for all these apps that can then get extended. So let's dive in a little bit into the structure of the individual apps, right? So what does this look like? So again, we're inside that apps directory, and we're inside an organization folder. So this is its own separate micro front end. And if we step through this, your source folder, so everybody here has probably done a Vue app, standard source folder, right? You have your composables, your components, things like that, all live in that source folder. The package JSON is for the app-specific dependencies, right? So anything that's a dev dependency is probably already handled in that root. So this file just allows for your app-specific dependencies that you need in your world. Again, the config files just extend that base. So the vconfig in each app is really just some deployment-related sugar, and there's not a whole lot of customization there. Same thing with the TS config. And then the Cypress directory. So at Kong, we do a lot. Most of our tests are regression tests for end-to-end testing, and then we also have like critical paths covered by smoke suites. So each app can then have its own Cypress folder where they can have their own configurations. They can put out their different configs. They can pull in different plugins that they need, anything they need with that Cypress configuration. Okay. So let's talk a little bit about this global component, right, that provides the global layout for Connect. So all our micro front ends, in order to be a micro front end, need to have this shared global UI. So that includes the sidebar, the nav bar, and the main content area you see there in the white. So rather than each app having to replicate this layout and keep their styles up to date, okay, something, we changed the color, whatever, we have this shared app shell component that all the micro front ends utilize within their root app.vue file. And so if we look here, each team then only needs to be concerned with the logic basically inside that purple outline in the middle, right? So as an example, Connect's primary app sidebar navigation is global, right? So those top level items. Each micro front end injects its own secondary navigation items that you see highlighted on the left as a prop passed to this app shell component. So the benefit of this is that external apps, so those other top-level navigation items, don't have to care when any of this navigation changes, right? So if I'm in this AVI products area, I want to change my landing page, I want to change any of these internal links that my users are able to access, I don't have to coordinate that release with anybody else. I don't have to publish that to another app and then propagate it across all. I can inject it into the app shell so that essentially I can do what I want. I'm independent. I don't have to worry about anybody else. So the second thing this app shell provides for us is that since it's required, it can also take care of a ton of the core business logic that you need to operate in the Connect ecosystem, right? So this covers things like authentication, retrieving and managing session user data, authorization and permissions, both fetching and evaluation, and that includes just-in-time permissions for any of the UIs. Managing the active Connect region, because we have global areas of the app and others that are region-specific, and essentially ensuring that those specific region API endpoints are utilized correctly. The shell also exports a Vue router configuration to ensure all apps can follow that same region and global specific URL structure that we have. And then it also provides a global notification and error UI, as well as all of our automated error reporting through Datadog. And so if we look a little bit deeper into the host application, right? So what does their app.vue file look like? So if we look here, we can see that, there we go. The app.vue file essentially just has one component, right? And you'll notice there's no router view here. So the Connect app shell itself provides that root level router view for the app to essentially inject its own UI into the shell. And so if we step through these, the sidebar items are provided just as a prop and defined down at the bottom. And if you can hopefully you can see that, this app's items depend on whether there's an active service in the URL, right? So it's a computed, it can be dynamic, it can essentially respond to whatever else is going on in the app. We also have our global error and loading states. So how this works is it's initially handled by the shell, right? Because the shell has to fetch permissions, make sure the user is authenticated and do these things. Once the app shell has determined the state of the app, it basically releases these props to be able to control it from the host application. So maybe the host app has to do a little bit of extra logic when it loads. That's fine. It can essentially take that over via the prop, show the loading state for a little bit longer, and then clear it whenever it's done. Our ready. Hello. Cool. So the ready event just allows the host app to notice when all of that initial processing is done, we emit an event. It can then release and do anything else it needs to do. And then again, so session data is controlled by the app shell. So utilizes a singleton under the hood that's exported by a composable. And then essentially whenever that session data is updated, we keep it in sync real time with the Penea store and the host app, so they always have access to the most recent data. And so with this architecture, there are a few trade-offs that we are just accepting for now, right? So apps are still housed in a monorepo. Is that bad? I don't know, it's probably subjective, right? So for us, this isn't the end-all solution for micro frontends. Again, when module federation is natively supported, we may dig into that a little bit deeper. But for us, this is subjectively better just because we can enforce these code quality standards and other developer experience improvements in one place instead of having to propagate that across multiple repos or importing all these shared configs in different places. The other thing is moving apps, right? So we haven't fully we fully committed, but we haven't fully finished moving to this architecture yet, right? So we've moved, I think, half of our top-level apps. But the biggest pain point here is change between teams, right? Or change in general. So if you need to migrate an existing app that's still going to live and function and be updated in the old structure, and then move it over to this micro frontend repo, one of the trade-offs is we have to track all of those in-flight features that are getting added, right? So, hey, did this thing get moved yet? No? Okay, cool, go ahead and update it. It did get moved. Okay, we also need to port that forward to the micro frontend architecture. So Jira is your friend as much as I'm not a fan because no. But again, tracking that is just one of the pain points, but it's worth it in the long run once you move to your new thing. Another trade-off is that the L2 navigation items are essentially not accessible without a user first navigating to the parent app, right? So if I'm a user and I'm on one L1 item, I can't just deep link from the sidebar to another app without first navigating to it. For us, for right now, that's worth it because it allows each app, again, to have full control over that sidebar, over their own navigation structure, and the other apps don't have to care. We could move this to some kind of shared config or something gets pulled in by an API, whatever, but we just haven't chose to do that yet just because of some other business requirements we have. And then the last thing is that in this architecture, if you want to navigate between micro frontends, it does trigger a full page refresh. So let's talk about that. Why does it reload? Because this is everything our product team asks us every other day. Why is the page reloading? This is weird. It's an SPA, right? It's fine. It's fine. And it's fine. Because basically, again, like we look at it as a trade-off because by doing it this way, again, without module federation, each app is independent and doesn't have to care about anything anybody else is doing, right? So to provide them with a seamless experience, we actually do a little bit of trickery with a custom Vue plugin. So we inject the same static loading template in the host apps, like as you see here, like your entry div. We inject that into the index.html, and then during the build, when the app starts to hydrate, that static loading template gets replaced with a dynamic one from the app shell, and it's essentially a seamless experience for the user, right? So again, is it great? Maybe, maybe not. But the example I give is this. So my hometown airport, if you ever take the last flight in for the night, they always park your plane at the very end, as far away from the baggage claim as you can get, right? So you then have to walk all the way through the airport, blah, blah, blah. But by the time you get to the baggage claim, your bags are already there, right? So did the crew sprint across the tarmac to make sure I didn't have to wait for my bags? No. But it gives me the illusion that my bags were there quicker, right? So that's kind of like what we're doing with injecting this static template, right? Like it's all about perception to the user. So again, like solutions can be iterative. So we definitely plan to improve this over time. But for now, to get us out of that monolithic structure, this is one of the trade-offs that we were basically accepting. So the next thing, let's talk about our build and deploy pipeline, right? Because everybody knows what micro frontends are, but again, we're doing it a little bit differently. So not to say this is the best way, but it's the way that's working for us in this current iteration, right? So we use GitHub Actions, S3, and CloudFront. And so when we look at how this works in our CI, a developer will go in, maybe they change one app, maybe they make changes in 3 because they're changing something that impacts over areas, right? So GitHub Actions determines what apps changed, and then it fires off parallel concurrent processes for each app, right? So each app's workflow runs in parallel in our CI. So the next thing, what do? So we upload these assets to S3, and so we maintain 2 separate buckets, one for the preview environment, and then one for release. Our release bucket is what production is actually served by, so we replicate that bucket across multiple regions. So each bucket is organized so that each app's assets are in their own folder. Buckets are essentially origins for the S3 distributions, right? So an S3 release bucket is the origin for the S3 release distribution. And then we also upload all the source maps so that our error mounting service has that for stack traces and things like that to make it available. The next thing then is our deploy stages, the deploy stage. And so we do that in 2 stages, right? Preview and promote. So the preview stage allows for our full EDE test suite to run in the preview environment that has already been published up before reaching production, right? So if any issues are incurred in the preview environment, it will essentially block the release to production. In the preview stage, we upload into a preview bucket via subdirectories based on the PR number, right? So instead of like just at the root of the organization app, we upload into an organization / PR number 22 index.html. Instead of at the root. So this allows us to use these directories for CloudFront origins for PR deploy previews. So we use those at Kong for our product and design teams to be able to review functionality. And we also use feature flags and things like that on the side, but this allows the actual environment to be deployed while it's still in the PR status without actually having to go to prod, which allows us to flesh out a lot of issues ahead of time and be able to review that functionality without anybody having to run the code locally. And then, so as part of that, we invalidate assets, right? So the assets are all fingerprinted so that the new release bundle that goes out to, that is promoted are automatically fetched from the browser at the next page load, right at runtime. For anything that's not fingerprinted, we have some things that aren't. We essentially just invalidate the cache on the release to force any request to download the new bundles. And then finally, we also can support emergency deploys with this, right? So let's say our CI pipeline is blocked because of those like flaky tests we talked about. That's fine. We have an emergency release workflow that allows publishing assets essentially directly to S3 so we can get around that GitHub Actions pipeline if we have to in emergency. And so once things are promoted, we don't actually publish again. We literally just grab the S3 preview bundle and it's literally a copy and paste into the promote bucket so that we know that functionality from the preview will be a 1-to-1 match for what goes into production. Okay, so then we serve our apps via CloudFront, right? So we utilize a custom CloudFront function to that looks at the host name and the request path when the browser request is received, and basically tells it which S3 bucket and asset folder to serve. So as an example, if I go to global/organization, CloudFront will evaluate the function and return a request URI of organization index.html, which will automatically load that host app's entry file. The same strategy allows us to do the PR previews, right? So instead of that root level folder, we just go into the PR folder and serve that instead. So it's fast on the edge, right? So the benefit of being on CloudFront is that it stores everything from the cache on the edge network after the initial request, and all the assets are cached after that first browser request, right? So if for some reason something isn't in the cache, it will grab it from the S3 bucket and then add it to the cache so that the next request is served directly from the edge network. And then global availability, right? So CloudFront is global, so it'll serve access to the user from the closest node. So our UI is just considered global in general, right? Not like our APIs. And then it'll reroute traffic automatically if there's an issue. That also allows us to do rerouting for things like planned downtime or a status page or something like that if we need to. So let's talk through some results, right? So how did we do? So our goal was to begin splitting up the monolith and enable teams to operate independently and improve our developer experience, right? Because it was, to be frank, miserable for a while to work. When I started calling, it wasn't great. I shouldn't say miserable, that's bad. But changing architectures is a big deal, right? Like nothing is easy. And so rather than trying to fix each one of these problems and getting to like whatever our end solution would be, maybe for the long term, we chose to kind of address those core developer experience issues that we could solve and do them in smaller manageable pieces, right? So you can see here the list of all the things we kind of did. We created the Monorepo, better optimized, autonomous team-based development, so we don't have to have those bottlenecks and things, better tooling, shorter feedback loops, and we made something that's scalable so that in this new architecture, we can grow as needed with the app. And so then if we look at the results of the timing, right, so we can see those before numbers on the left, and now look how much better we did now, right? So we were essentially at 90 minutes from PR merge to deploy. It's roughly 13 to 15 minutes now for a single app. You can see our GitHub Actions minutes dramatically decreased, right? Because we're getting rid of all those smashing that rerun button between developers. And we're also able to merge a lot more code and get it released, right? So we more than doubled our pull requests per week. And the same thing with those host app deployments, right? Those numbers shot up as well. And we were able to attribute the GitHub Actions minutes to the reruns, which is nice. And again, this is a shorter feedback loop for all our developers, so it turns out and in turn gives us better code quality and allows for more rapid development among teams. Excuse me, I covered the wrong thing. So why did we do this instead of that, right? Like, what are other options that we could have done? So DeHaven kind of talked about there's no module federation support currently as a first-class citizen in Vue. So we looked at it a little bit differently because one of the things with module federation or using single SBA is that they typically require some shape or form of a centralized host app along with additional builds and deploys that take place when any of your micro frontends are updated. So with our strategy, since each one is deployed independently, the organization app could be up, the API products app could be down, and they don't impact each other, right? The user, bad experience, but the user can go to one and not other, and the teams don't have to care. Another option would be to publish each app as a package bundle and dynamically import it at runtime. Let's say from a CDN, you could import those assets. Maybe we'll look into that in the future. We'll definitely look into the module federation when Vue supports it from the get-go. And again, this isn't our final solution, right? Like, we needed to get from where we were, which was a poor developer experience, something that it was painful to work in, code took forever because of all the failures. We didn't have teams that, there was no single person that had all the knowledge to go from, this app area to this app area. You had to pull somebody in every time to resolve issues. So moving to this architecture was the next logical step for us and allows us to be able to evolve the application in the future for the better, right? So step one, get everybody broken apart, and then step two, we enhance it, we optimize it, we make it better, and allow our teams to enhance the app. Cool, that is really it. I'm gonna share the slide link again. And I think I'm okay on time, but if anybody has any questions.
You thought you were okay on time. No, I'm just playing.
Maybe not.
Thank you very much for that. Now we're going to get to some questions. We have one right away here. And we have two more here. I love the preloading of questions here. Yeah, like this performance thing. I thought I saw a fourth one there, so you got fans. Okay.
Yeah, does it flicker when you switch between the apps?
It doesn't flicker. So again, since we're injecting that static loading into the actual template, instead of that like white page flash you see, that static content is rendered instead. So it's available as soon as that index.html file loads. So it's there as soon as the DOM loads, it is there. And then the app shell takes over with that dynamic loading template. So since they're a one-to-one match, it's essentially seamless between the two.
Okay, all right, thank you.
Thanks.
So yeah, one question is around the shared app shell. I'm just wondering if you've run into any gotchas or challenges when it comes to coupling between that and the various micro front ends and change management if you need to make a change in the app shell. May not have time, but one quick second one was related to that. For when you're going from a full page reload like that, when you're going through that reload, have you looked at all at using the new Vue Transitions API and if that can help smooth that at all?
I'll answer your second question first. No, we haven't looked into that. But as far as keeping everything in sync, so since all the dependencies are tied in the monorepo across the micro front ends, right? We use Renovate instead of Dependabot. If anybody's familiar with Renovate, works really well natively with PNPM. But it will automate those updates. So we have some specific rules in place for our internal packages where the time to live essentially on NPM is something like 2 hours because it's gone through all of our own testing, right? And so it will automatically create a PR to pick that up, and then everything essentially gets deployed with that single PR. We actually do have a little bit of architecture that wasn't shared here, which is we have some apps that utilize the shell that are not in this monorepo. With those, we handle it with semantic versioning, right? So if we are pushing something out that has a like user-facing breaking change, so let's just pretend our nav bar went from like yellow to purple or something like that, right? It's going to be very visual. Maybe it's not a breaking change, but we use semantic versioning to basically say, okay, that's a breaking version. Now that app has to be updated manually across so that if you go between the two apps, right, they need to serve that same UI. So we do essentially some coordinated releases there. So we will pick, downtime or something like that when our app doesn't have a lot of traffic and roll those out. There's with this solution, there's always going to be a little bit of a race to prod between the things, right? But that's how we handle it, right? Like from everything being that core app, as long as you unify those dependencies, and then again, a little bit of coordination on the side to cheat, as long as you're okay with that little variance for whatever it is, 5 minutes or maybe not even that, then we're okay with it. But if you want to ask more later, feel free to.
Thank you very much. Give it up for Adam.